In this video, we'll do a function and a graph analysis for an absolute value function. Our question is, for y equals the absolute value of x plus 3, give each of the following: the y-intercept, the coordinates of the vertex, the linear function for x values less than or equal to the vertex x value, and the linear function for the x values greater than or equal to the vertex x value, and the graph of the function with everything labeled. Notice that this is a general approach, and if you had a different kind of function, for example, y equals the absolute value of x minus 2, you can apply the same ideas. So let's start by creating a t-table. The y-intercept is when we put 0 into our function. So the y-intercept, y of 0 is 3, is the coordinate point 0, 3, which is shaded on the t-table. Now, our vertex is when x is negative 3, which is also shaded on the t-table. Notice that this is the low point on the graph and that there's this symmetrical increase on either side of x equals negative 3 of our y values here. So we're thinking that this is shifted left 3, which matches what we learned in homework video 3.1.1. So our vertex is negative 3, 0. So we have that graphed here. And we have our y-intercept here. Now, we need to find these two linear functions. So for the function in 3, which is when the x values are less than the x values of the vertex, so x is less than or equal to negative 3, we need 2 points to find this linear function. So we have our vertex, negative 3, 0, and then we've just randomly picked x equals negative 5, 2, another point on this linear function here. We can use those 2 points to compute the slope and see that it's negative 1, which makes sense. And then we can solve and determine that our y-intercept of this linear portion, not this part of the graph, but this linear portion on the left where x is less than or equal to negative 3, will be, the y-intercept will be negative 3, so down here. So altogether y equals negative x minus 3. Now for the function in part 4, so the line over here, we have 2 points marked on our t-table, our vertex and the actual y-intercept of this original function. So we can use those 2 points and find that our slope is 1, which is actually making sense. And then because we actually already have the y-intercept here, we can just conclude that our function is then y equals x plus 3 for that piece. So let's check this out. If we graph all these points from our t-table, the t-table and the graph match, the y-intercept and the vertex on the t-table matches the graph, and the linear functions match the graph. Now notice that this linear function, there's a little dotted line here to just show you to think about how that y-intercept would come into play. This dotted part is not part of this function. It's just there for demonstration purposes. So our answer is the y-intercept is 0, 3. The coordinates of the vertex are negative 3, 0. We're shifted to the left 3 here, but no up or down. The linear function when x is less than or equal to negative 3 is y equals negative x minus 3. That's for down here. And the linear function when x is greater than or equal to negative 3 is y equals x plus 3. That's this part here. And then the graph of the function is shown.